Hi everyone, this is Praktis Sumatif of Chapter 2, Paper 2, question number 8. So we have an open right circular cone with the base radius RCM and slant height of 12 cm is used to cover a ball with radius JCM such that the ball is inscribed in the cone as shown in the diagram. So in other words, the ball fits just nicely in the cone itself. So we have to show that the volume of the cone is given by V equals to pi over 344 H minus H cubed. So it is written fully in H. So usually when we need to find the volume of the cone, it is 1 over 3 pi r squared H. So we have to change R in terms of H. So how is R related to H? So from this diagram, we can actually divide a cone into two parts. So it forms two right-angled triangles. Let's just get that triangle out. So we have right-angled triangle with the height h, the radius r, and the hypotenuse 12. So how is r and h related? We apply the Pythagoras Theorem. So r squared plus h squared equals to 12 squared. Therefore, r squared equals to 144 minus h squared. So substitute this into our formula of the volume. So we will have pi over 3. R squared is 144 minus h squared times h. So we have just shown that V can be written in pi over 3, 144h minus h cubed. So done. And next, we have to determine the dimension of the right circular cone. That means you need to find the value of r and h so that the volume is maximum. Okay, so V will be maximum when we differentiate V with respect of h equals to 0. All right, so let's look at the V. Let's write the V, multiply the pi over 3n. So we have 48 pi h minus pi over 3h cubed equals to 0. So I open up the bracket first. And now let's differentiate it. We have 48 pi minus pi h squared equals to 0. So pi h squared equals to 48 pi. Therefore, h squared equals to 48. And 48 can be written in 16 times 3. So h will be square root of 16 times 3. We have 4 third 3. So we have found h. And then from there, we can find r. Because r squared equals to 144 minus h squared, which is 144 minus 48, because h squared is 48, and we have 96. Okay, and 96 can be written in 16 times 6. Therefore, r will be the square root of 16 times 6. We have 4 third 6. So we found the height and the base radius of the cone. And next, we have to test if this gives us the V maximum. So we can test that. How? We differentiate the V twice. So let's differentiate that second time. So d2h by dv by dh2, okay, equals to, this is the one. Let's differentiate this. We have negative 2 pi h, and then with h equals to 4 third 3. So our second order of derivative of volume will be the second order of derivative will be negative 2 pi times with 4 third 3. So from we don't have to really count the exact value, but look at the number. We know that it is less than 0. Therefore, it will be like the set phase graph. Therefore, V is maximum. So V max when h equals to 4 third 3, and also at the same time, the corresponding the corresponding R value will be 436 cm. Okay, now, so the next part is to find the value of J, the ball. Now, how do we do this one? Again, we can use this right angle triangle. Okay, we can use this right angle triangle because we know that, let's look at this triangle. We know that this is J. Therefore, this whole thing, if I were to divide this part, okay, into two equal parts. So the angle here, let's call it alpha. They are the same, right? Since the ball is inscribed in this cone, so this side, the side here, basically, they are the tangent to the ball, okay? And tangent means it makes 90 degrees with the radius of the ball, okay? And therefore, if, okay, 12 is the whole thing. 12 is the whole thing, but this is R. Okay, this is R. So we can use the trigonometry ratio to solve this part of the question. Let's just get that triangle at the bottom here. Okay, the height is 4 sub 3. This is 12, and the base is R 4 sub 6. So we can find this angle first. So isn't it this angle is 2 alpha? Okay, 2 alpha. All right, so from here we have another right angle triangle. Let me just put that down first. Here. So the J is here. Okay, this is the J as well. Okay, I'm going to find the alpha first. So with the 2 alpha, we find the we can find the value of the alpha by taking any of the sides. So we can use the opposite over the adjacent. So tangent, we can use tangent. Sine or cos can be used here as well. So no worries. So we are looking at the blue triangle. The angle is 2 alpha. So tangent 2 alpha is the ratio of opposite sides to its adjacent side. So 4 sub 3 over 4 sub 6. Therefore, 2 alpha will be arctangent of sub 1 over 2, because this one's simplified, and we can combine the sub 3 and sub 6. Okay, so to find the value of 2 alpha, we need a calculator. Let's get shift tangent to call out the function of arctangent of 1 over 2, sub 1 over 2. 1 over 2. Okay, let's see, we have 35.26 degree. 35.26 degree. And to find alpha, that will be half of that. So let's take this divided by 2. Okay, so we have 17.63 degree. 17.36 degree. Now, so with that, let's look at let's highlight the right angle triangle this with green. Okay, with green highlighter. So now we can find the value of J. So how do we find the value of J? We have the J is the opposite to the angle alpha, and we need to use the adjacent side. So opposite and adjacent, tangent as well. So tangent alpha, which is 17.63 degree, equals to J over 4 sub 6. So J will equals to 4 sub 6 times with tangent 17.63 degree. Okay, so let's get the calculator. So we take 4 sub 6, multiply with tangent 17.63. Okay, 3.114, right in the 4 significant figure, 3.114 cm. So we have found the value of all the unknown here. That is the R, the H, and the J. So that's it for question number 8.